So, Kelly, you joined Oklo earlier this year as a mechanical engineer. But before joining Oklo, you had some pretty epic jobs, I would say. And you found yourself working at SpaceX. And not every day I get to talk to somebody that have worked there. So I have some questions for you. I would love to hear from you, sharing a little bit of background of what you did there and what are some valuable things that you learned during your time at SpaceX.
Yeah, so I worked at SpaceX for 3 years, and I spent most of my time there working on the composite landing leg structure that was part of the Falcon 9 and Falcon Heavy launch vehicles.
Very cool.
And yeah, I worked on a team of about 11 people for most of my time there. And it was fascinating to see the company grow just even in those 3 years. I came in at when it was about 3,000 employees, and when I left, it was about 7,000 employees.
Oh, wow.
So a lot of growth in the company. During my time there, they landed a booster for the very first time. We reflew a booster for the very first time. And a lot of that did depend heavily on my work on the landing legs. And my main job was basically the redesign of the landing legs. So the very first landing legs that we designed were just kind of like a scrappy, get the job done. Like, can we even land it, period? Like, will it break and the booster will topple over? So what I ended up doing was, yes, we got that design, but it wasn't really well suited for reuse. So to actually design a landing leg that could be landed and flown a total of 10 times through that whole cycle, um, landed and reflown, I guess. And so that ended up, we redid the entire architecture of the landing leg, from the manufacturing method to the testing and the analysis, and I was in charge of most of that. I even got to like help with the installation of the landing leg, which involved, like, of the very first one, which involved going to the launch sites at Cape Canaveral, craning the landing leg over top of the booster and making sure that it would fit, and such that our installation, when we had to do 4 of them in assembly when getting them ready for launch, would go smoothly.
Wow, incredible. Were there anything else that you wanted to highlight? Because I know that from one epic job to the next, you accepted a research position and you moved to the South Pole for this position. I would love to learn more about that and what was that experience like for you?
Yeah. Also, I do realize that I forgot to answer your question of like a lesson learned. And there was one really salient one that I did want to highlight at SpaceX. And I
Yeah.
think that the primary one I came away from was make sure you're asking the right question.
Mm.
You could spend so much time and effort chasing an engineering question or problem down to realize that it didn't actually matter and that there was a different question that needed to be answered. So bringing things back to first principles and saying, why are we asking this? Is this the right question to even ask? What are we trying to understand and what are we trying to accomplish? There's often ways of answering things that you wouldn't have thought, and doing that with people and collaborating with people to make sure that a lot of bright minds are coherent and congruent on whether or not we're asking the right question. I thought that exercise could save hours, weeks, years even off of a design cycle.
Yeah, I bet. And that's an exercise that you can really apply in a lot of engineering situations, I'm sure.
Yeah. So you asked about the South Pole.
Yes.
I had decided that I was ready to move on from SpaceX. I loved my time there, but I had started thinking about why it was that I even came there in the first place, because I was starting to get to a point where the long hours were taking their toll, and I was starting to feel like I should reassess and see if this is still something that I believe wholeheartedly in, and if this sacrifice is worth it. Like, if I really do feel that this is part of my purpose, then all of the hours worth it. But if it was no longer, like, as we grow and we change, sometimes our values change. So I took a second to kind of step back and look at, what is it that I value? Why did I even come to SpaceX in the first place? Kind of revisiting that question. And I realized that what drew me to SpaceX, aside from being a technologist and aside from rockets being really cool, and my love of space, was that ultimately its mission statement being to colonize Mars, to make humans interplanetary. At the root of that is looking out for humans' future, like basically ensuring our continued preservation on Earth. Um, and when I looked at that statement, I almost felt a little silly because I was like, this is great. There definitely should be smart people working on space exploration, but I also recognize that we have another essentially existential crisis for humanity going on, and that is climate change. It
Yeah.
almost felt like I was working on my vacation home, trying to work on colonizing Mars when my regular house was on fire.
Oh, I
And I was
love
like,
that analogy. Oh, that's brilliant.
yeah. And I mean, I really do believe that people should still be working on space exploration because I kind of see the future unfolding. Like, if you look back in time, basically around the 1970s and the 1980s really was the start of the information age or the digital age or what have you, where the rise of Silicon Valley and the huge technological leaps and bounds made in microchip processing and computer technology basically changed the way that humans exist. It changed everything. It changed the entire infrastructure of society. And that was a really big step function in humanity's evolution, I believe. And
Yeah.
we're still kind of like seeing the plateau of that step change, and I'm seeing the next one being energy. Like, I really do think that we're at this um, pivotal point where if we don't redefine the way that we power humanity, which, the global demand for power is increasing, and I think that it's only fair that the civilizations and the developing countries that are coming online to the electrical grid have access to the same luxuries that we have. Like, I do not believe that we should be putting them on limited power, such as, the very efficient and very thoughtfully engineered renewable systems that they're building in countries such as India and China, where we're putting new cities online or new developing areas online. I think that that's a good idea, but I ethically don't agree with it because we are the first world country. We created the problem of climate change and excessive CO2 emissions. It shouldn't be the burden of the developing nations to deal with our problem, right? They have every right to the same luxuries of energy that we do. So ultimately, the question is, how can we continue to keep up with humanity's increasing energy needs while giving everyone the same access to the power and luxury that the first world has, while simultaneously finding a sustainable solution for that? And so when I looked at that question, it was like, okay, wow, like, what do I do with my like background in aerospace? Like, how do I switch to working in energy? Like, that's such a big jump. Like, how do I even decide how to do that? And so when I was at this point in my career, when I was asking that question, it basically took me a whole year to answer, like, what next from space to energy. Like, where can I be most effective? What calls to me the most? And so in that time, I kind of was just ready to leave SpaceX, and that's why I decided to go to the South Pole. I actually was applying to the position mostly for fun, really, because I had heard that it takes often people several applications to even get considered, and I did not expect to hear back. But apparently, I'd gotten really lucky. The competition varies a lot year to year, and I don't know how competitive of a year it was for me, but the main thing is that there were no incumbents coming into the role that I was applying for. So that definitely helped. And I got a call back and I got the position. And so I was like, wow, I mean, I don't know what I'm doing long career wise yet, but I definitely will not say no to spending a year down at the South Pole. That year ended up being 2020, which was a crazy year to spend away. I'm
Yeah.
still kind of reeling from, like, I came back in December of 2020. I'm still very much reeling in the shock of, like, oh wow, like, it felt like I was on another planet. Like, we often would joke that, like, oh, back on Earth, what's happening? Like, watching 2020 unfold and COVID unfold, the global pandemic unfold from afar really felt like watching reality TV of a show that was unfolding on another planet. Like, it was so surreal, didn't feel real. And now that I'm in it, it's like definitely a culture shock.
I
um
bet.
But yeah, what I did down there was I was a research associate working on basically the maintenance and upkeep of several different projects in the field of aeronomy, which is essentially study of the interaction of the Earth's upper atmosphere with solar wind. And we were specifically looking at the cusp zone of the Earth's magnetic field. So where those magnetic field lines turn in at the poles is why that field is researched so heavily at the South Pole, just to see how that affects that interaction. So that's often why you get the aurora borealis, the aurora australis at the South Pole. But it also can inform us like how that interaction might affect things such as effects on GPS satellites, effects on induction on the electrical grid, those kinds of effects from the solar wind and extragalactic particles.
That all sounds so fascinating. And just to back up a little bit, I think you're just being so modest. I'm sure they saw your experience and just have to have you as a part of their team. So I think you were being very modest. It sounds really fascinating, but also challenging at the same time, too. I'm sure you likely didn't get a lot of sunlight, for example, and other challenges when during your time working there. And I think that'd be tough for me for sure.
It is a very challenging experience, and they specifically do interview quite thoroughly for personality fit in a crew because, just to kind of back up, the experience was wintering over at South Pole, which involves staying through the austral winter, which means 6 months without sunlight. And it's a crew of only 42 people during that time. So in February, which is like sort of the austral fall season, like heading into winter, that's when the last plane with any other people, cargo, fuel, anything lands at South Pole. After that, it gets too cold to land there. There's actually only one plane in the entire world that can land at South Pole during the winter, and that is because it doesn't have hydraulic landing gear. With hydraulic landing gear, it's too cold in the South Pole, and also it's dark, so it's dangerous. There isn't the infrastructure of like a landing strip, etc. So definitely very physically isolating, and because of that, and being with such a small crew dynamics are really important, and like personality fit with the crew is something that they screen heavily for. I personally felt like it fit me like a glove, and I like cherished every time. I still look back very nostalgic on that experience, but I think the hard part has been coming back. Like we get so like humans are amazing in how we adapt. Like I adapted so well to that atmosphere, and for a lot of people it's challenging kind of fitting into a very monotonous, like it sounds like a really cool experience where you are going to the South Pole, like it's Antarctica, and yes, there's a lot of novelty in the beginning, but once you settle in for winter, it is a long winter where you have the same exact routine every single day, the same faces every single day. You eat all of your meals in a galley with the same people every single day, and your job is more or less the same every single day, which sounds like awful for especially like a person who like I love to live like a very dynamic life, and change is great, but like you also kind of get very comfortable, and you almost feel like it's like a cocoon of familiarity that you settle in, and you develop such lasting friendships, and like the community that came out of that I felt like was one of the like closest knit communities I have ever been a part of. And then to go from that to COVID, where I basically started remote work right away, I was going from the most intensely social experience of my life, like eating 3 meals a day, 7 days a week with anywhere between 5 to 35 different people, like to like 24/7 being alone. Like that was like I had to go through some mental leaps and bounds, and I still don't think I'm quite right in that, like going through that adjustment, especially being an extrovert.
I can relate. It's definitely a challenge for sure. And we are over a year into this, and there's just, for some of us, there's no way of adjusting really. And
Yeah.
it's just such an interesting time that we're living in. But thank you so much for the work that you did there. I'm sure as much as the the incredible experience that you had and the amazing connections that you made with the rest of the crew. I'm sure that there were a lot of challenges too during your time working there. So thank you so much for your work there. And I'm really interested to learn more about how you became interested in wanting to transition into working in advanced fission and how you even
Yeah.
Oklo.
So kind of visiting back that exploration that I had mentioned of like how do I get back into, or how do I get into energy? Never having worked in the field, not really even being familiar with like what the entire state of energy looks like on a global level. And so I took a step back and I was just like, okay, so, climate, we'll start with climate change. And, it's pretty well known that CO2 emissions are the problem and they're still on the rise. And that the primary source of those is burning fossil fuels for energy production. We definitely get a little bit of that from transportation, and there's a whole like spread of different sources, but energy production is the predominant one. So then looking at energy, I was like, okay, how can we get off of fossil fuels? There's renewables, and then there's also nuclear power. And I basically determined that there's two key technologies that are essentially the frontier of energy, and those are energy storage, such that we can deal with the intermittency of renewables, and nuclear power, both fission and fusion. So
Mm-hmm.
looking at that, I basically looked at those three different things and decided that both fusion and energy storage are pretty far out technologies. Like I believe, this is just my own kind of personal estimate, that it's going to be on the order of decades until we have either one at technology readiness to really employ on at scale for global energy needs. And meanwhile, we have a technology that's ready, that's been ready since the 60s, that is nuclear fission. And so the way that I see it is nuclear fission needs to be implemented now. And that can buy us some precious time to kind of curb, to flatten, not only flatten, but then start to like decrease the amount of CO2 that's in the atmosphere instead of increasing it. So that can buy us the decades that it will take to properly develop energy storage such that we can move to a fully renewable energy production. And that's what I believe should be the direction of humanity eventually. And so I view fission as sort of a stopgap technology, but a critical one at that. Like we need that right now to deal with the crisis of climate change, which will not wait for us to develop energy storage technology. So when I had basically honed in on that from looking at what I believe to be the frontiers of energy, I thought about fission and I was like, okay, well, what's going on with fission? And I found to my dismay that not a lot in the United States. And as a matter of fact, it's probably the only field where the United States is drastically behind. I don't know that for sure, but it seems like it. That the United States could definitely use some advancement such that we can start to compete with countries like Russia and China, which are starting to develop technologies that other countries want to buy. So I think when I saw that, I was like, okay, how do I get involved with fission? I don't know anything about nuclear fission. And I just basically was starting to ask these questions while I was at the South Pole. And when I was there, I was looking at energy production at the South Pole, just being interested in energy in general. And I'll just talk a little bit about that. So the South Pole has a power plant that runs at about 750 kilowatts, and that generates power for running, keeping the station lights on, the warmth, the water heating, like generation of water from ice, and also the operating the science equipment that goes down there. So there's like South Pole Telescope, Bicep Array, Ice Cube Neutrino Observatory. All of those are pretty energy hungry, and so most of that power goes towards powering those that science equipment. And where that power comes from are diesel generators that burn AN8 jet fuel. And the over the course of an entire year, the South Pole power plant consumes 500,000 gallons of this AN8 jet fuel. That's a lot. uh, to how they get it to the South Pole, which is 1,000 miles off of the coast of the United States' primary Antarctic base, McMurdo. So it's 990 miles away from that. Is we either bring it overland or fly it. So about a third of that 500,000 gallons of AN8 jet fuel comes in via the LC-130 Hercules aircraft. It's flown in, and the reason we use AN8 is because you can just put it in the aircraft's existing fuel tanks, and you don't need any extra infrastructure to carry the fuel.
Mm.
And the efficiency of that is it takes 2 gallons of fuel to carry 1 gallon of fuel to South Pole.
Oh
So
my
that's
God.
not very efficient.
No,
Yeah,
not
and
at all.
that's what you do for 1/3 of the fuel. So the other 2/3 of the fuel is even crazier. That goes over land via 3 different traverse missions, which is essentially a team of 12 to 15 people and 5 to 6 Challenger tractors that go 5 miles per hour over land, the 1,000 miles from McMurdo to South Pole. And they carry these massive fuel bladders, and that's the 2/3 of the 500,000 gallons of fuel come via these 3 different South Pole traverse trips, or spot trips is what they call them. And they use ground penetrating radar to search for crevasses. They have to navigate through the Transantarctic Mountains. It's a trip that takes about 30 days. And it's just like crazy how much overhead there is. And this is just to keep the lights on at South Pole Station. So I looked at that and I was like, wow, that is one, a lot of mass, like a lot of fuel, just like moving the fuel around is like this huge ordeal. A lot of people, a lot of hours. It it was just crazy to me. And I looked at those numbers and I did an energy density calculation just to see like with current technology, like not even taking into account advanced fission reactor technology. So just with like the traditional light water reactor technology, efficiencies of about 30%, um, and the density of uranium fuel, it would be the equivalent of 1 kilogram for an entire year. I could hold it in my hand, like,
Yes. Yeah.
right? Like I could hold 10 years worth of fuel in my hand for the South Pole. Whereas like we're doing these massive trips, these like we're spending money on the air guard, the all of the flights, it just it's mind-boggling like how much fuel, like fossil fuel, needs to be transported just for power. So yeah, I started to realize like, wow, this is an example that really highlights the pure energy density of uranium fuel and nuclear power. Like it's 2 million times more energy dense than fossil fuel.
Exactly. And hearing from someone that has that experience and did the math, you summarized that so eloquent and beautifully. Nuclear fission is just incredible. So to sum it all up, do you mind sharing your thoughts on how Oklo can fit into the future of energy?
Yeah, I guess I sort of spoke about this a little bit earlier, and how I see the next few decades to be really pivotal in essentially humanity's existence on Earth. Like we have to figure out energy, otherwise climate change could detrimentally affect our population, if not wipe us out. I mean, I'm not usually an existential thinker like in that sense, but I think that I view it kind of like a credit card, right? Like the earlier you pay it off, the easier it is. Same thing with dealing with CO2 emissions. Like the earlier that we get ahead of this and the earlier we stop burning fossil fuels, the less displaced people from rising tides we have to deal with, the less changes in our agricultural infrastructure, since the warming climate is going to change the way that the entire planet generates food. Like if our normal like corn belt in the United States shifts north, like how is that going to affect the entire economy? Like our agricultural system to feed the planet is not set up for such drastic change. So I think that um, employing nuclear fission, which is a technology that's more or less ready to go today, it just is a matter of commercializing and deploying these advanced fission technologies and getting the licensing ready for that. If we can get that out in the next decade, then we can significantly avoid a lot of the outfall of climate change. And I think that that will actually help buy us the time that we need to develop the energy storage systems that are needed to convert electricity production to fully renewable. And I sort of see this whole shift in how we think about energy as, going to take up the next 50 years, essentially. Like that's my rough estimate. My personal opinion is that, like, we can deploy nuclear fission in the next 10 to 20 years, and that will buy us some time to start getting onto a path towards fully renewable. And probably by 2070, I would say that if we have not fully achieved a fully renewable planet by that point, we will at least be on a fairly sure trajectory towards that. So I view the next 50 years as really the age of energy, as I like to think about it. So we just came out of the digital age, or the age of information, and we are entering into this awesome period in humanity's evolution, which is the age of energy. Because, like, the digital age was awesome in that it just, like, everything digitized, and the way that we even interact with each other is so different with our phones and everything. And computer technology and computing has completely changed the way that we do everything. But the age of energy is going to be a completely different step function. It's going to be where we really need to think differently in how we even produce energy. It's a much more mechanical problem. Like, nuclear fission is about the physics of, like, how can we get the fission to create a chain reaction and generate heat to generate power, while also effectively removing that heat in a safe manner. That's a very physical problem. And energy storage is also a physical problem, whether you go for chemical, like, and you're dealing with chemical storage such as batteries, or you're dealing with physical storage such as hydro pumping, like up a mountain and then running it back down, or even the crazy methods of, like, during the day when surplus solar energy, or energy from solar is surplus, you pick up massive weights with a crane and then you drop them down at night. Like, whatever it is, it's just a much more mechanical problem. And so it's very interesting to see, like, how humanity is going to really rise to this challenge of, like, how do we reconfigure the way that we think about energy? How do we move the electrons such that we can do this in a sustainable way? I think that's really exciting to be going into this age of energy, like coming out of the digital age. And I think that the most exciting thing about that, me being a space lover, I have to say, is once we're on a path to fully renewable, there really is nothing stopping us from entering in what I like to call the age of exploration. Like, I really think that that is going to be what is next after we get to fully renewable. Once we have a planet where everyone has access to fully renewable and sustainable energy, and developed worlds are even coming online, and they have the same access to the luxuries that we have, like, really, there is not anything stopping us from, like, deploying amazing technologies for space exploration. And if we have, like, essentially, like, limitless energy at our disposal, if we've been able to basically, like, corral the sun's power, and we have all of that at our disposal, there's nothing stopping us from developing the technologies that we need to explore other planets. So I think that the next century is going to be a really, really exciting one. We've got the age of energy coming up, starting now, and then after that, the age of exploration, which is why I'm so glad that there's still my colleagues at SpaceX working on that, so that we'll be ready. We'll be ready when we when we have renewable power. So yeah, I think that it's an exciting time.
The age of energy. We have to coin it somehow. Love it.
Yeah,
And
yeah, we should.
and just hearing you speak about that, I have goosebumps. It is such a critical time right now. And then something that we've been saying for a while now is making sure that people can subscribe to clean, affordable, and reliable energy. That's so important and will make all the difference. I see a little pup making an appearance.
Yeah, my rescue pup.
Thank you for closing this interview off with such inspirational words for all of us. Thanks, Kelly.
You're welcome. Thanks for taking the time.